Hey, good morning, everybody. Awesome. You know, judging by how many people I saw at the bar late last night, I'm super happy this many people are in this room. So thank you all for showing up. Cool. So hey, my name is Schoennagel. I'm the lead evangelist for the Americas. Super happy to be here in Copenhagen. It's my 6th year here at Unity. It's probably my 20th Unite. I get to have the fun of traveling around the world and showing you all some very, very cool stuff. So today I'm going to talk about the Heretic. And pretty sure most of you have seen the Heretic. Has anyone not seen the Heretic? Not a single hand, so that's awesome. But I'm going to show it to you one more time because we're filming, and I want to make sure that everybody who watches this on YouTube later gets to see it. So going to dive right in. I'm just going to show you part 1. We all saw part 2 last night, which was unveiled. This talk is going to mostly talk about the stuff that we saw in the first part, which is fine because part 2 is just a continuation. So to start, I'm just going to kick it off. I'm going to get out of PowerPoint really quick. And rather than just run the video file, I'm actually going to launch the executable, show you running this in real time on my laptop. This is a pretty sweet laptop. It's got a NVIDIA 2080 in it. So, you know, it's got some oomph, but it definitely runs faster than 30 frames a second. It actually runs at about 50 frames a second in the editor. So we're going to watch it playing in real time right off my laptop, and then we're going to get into how it was made. So here we go. Could have timed that a little better. Here we go. There we go.
This is the place. Doesn't look like much. Go take a look. Yeah, got it.
I could probably move the mouse.
Okay, here we go. So who exactly is this guy? You're kidding. They're a fairy tale, Boston. Don't be an idiot. I see it. Open it. Wait. Do it. Can't believe this place is actually real. This makes no sense to me, Boston. But he might happen to be right.
Yeah, right? All right, sweet. So we're going to do most of this presentation in the Unity editor. I do have a few slides to show you just to kind of set some of that up. So I'm going to dive right into this. So this was created by the Unity demo team based in Stockholm. I am not part of that demo team. I wish I was. They're the ones that make the really crazy cool demos that you see. A lot of them are here today. It's actually a pretty small team. They've got some other talks that are going to go a little bit more in depth than what I'm going to show you, but I think I got some pretty cool stuff to show as well. So they're responsible for the blacksmith, which showed off Timeline when that just came out. Then when Atom premiered, that was really to show off HDRP, Cinema Machine, and some of the cool tools in there. And then Book of the Dead was last year's creation, and so this year was all about the Heretic. So again, it's a small team based in Stockholm, and just absolutely love the work that they do. So yeah, this year was the Heretic. So one of the big challenges for this presentation, you probably heard a little bit about this last night at the keynote, was we really wanted to focus on creating a photorealistic digital human. And you know, my background is 3D animation, visual effects. It is the hardest thing to do is the human face. We all look at them every single day. Everybody notices those tiny little nuances that make a face what a face is. It is the hardest thing to recreate. I've tried my whole career to get a perfect one. You know, this is about as good as it gets. It is definitely a trick. So I'm going to show you some of the different techniques that they use, some of the different techniques that they try to use to get this to be the way it is. I think they did a fantastic job. So they started off, obviously, with some concept art, as one should, and you can see that it really didn't change a whole lot from the final that we saw. We have two characters in this project. Gawain, you'll hear me say the name Gawain a few times. That is the hero character. And then he's got this robotic bird, and the bird's name is Boston. So when you hear me talk about Boston, we're talking about the bird. And again, Gawain is the hero character. So the team tried a bunch of different techniques to get the face to behave and to work the way it should. So they started off with an actor. This is the actor. You can see he looks very similar to, am I projecting right? Yes, cool. Very similar to, actually looks pretty much identical to the version that we have in the editor. So what they did was a 4D capture. What's a 4D capture? Basically, we have the actor sitting in a room with a bunch of still cameras around him. Every frame, 60 frames a second, those cameras are firing and capturing his animation. And then using photogrammetry, that is then turned into a 3D model. So photogrammetry is, of course, when you take a bunch of different angles of a photograph and are able to then build a 3D model out of it. So you get a very, very high-resolution mesh, everything down to the little pores, all those little bits. In case the actor didn't perform exactly what they wanted to do, or they wanted to put some animation on top of that, they use blend shapes, and they use this snappers rig to do that. It's not used very much in the project. They found that as they were working with the 4D capture, that behaved really just about as good as they needed it to do. There are a few cases where they wanted some more extreme expressions, get the eyebrow to raise a little bit. I'll show you that in the editor. And so that's where the snappers rig comes together. And then all that stuff was combined to give us the final rig that we see, or the final face that we see in the project. One thing, of course, is you have your mesh and your textures. The textures are brought into Photoshop. They're tweaked. They're really made to look, just perfectly spectacular. But all that comes, again, from the 4D capture. Then we have the interesting issue of the eyes and the mouth. You obviously can't capture, well, I shouldn't say obviously. Capturing eyes is very difficult. You have pupils, but they don't make good markers. When you blink, things go wrong. So generally, the traditional way of doing this type of work is you do the eyes separately. You hand animate that. But they were able to use dots and ECS to basically make it so that at real time, at whatever frame rate we're running at, those eyes are locked into the sockets and moving around appropriately. So wherever the head moves, those eyes are welded to it, welded to those vertices so that everything moves appropriately and you don't see any kind of wiggle. There's no jittering in there. Works perfect. Same with the mouth. All that stuff is just seamlessly attached to it. From there, they use the standard HDRP stacklit shader. Every single shot in this, every single object is using the base shader. They did extend it on a few of the objects, things like subsurface scattering, they extended it. I'll show you some stuff they did to the eyes. But they just took those standard shaders that we have, like any one of you could do if you knew how to do it, if you have the skill to do it, and extended that shader. So there you go. We're going to talk a little bit about the hair. There's not a whole lot of hair, obviously, on this character, but there is some that we can show the new hair master node. The lighting rig, a little bit, two different rigs here. We've got the environment lights, which I'm going to talk about quite a bit, show you some different environment lights in there. And then we also had a separate light rig just following the character, so we could be really clear or really focused on exactly how we wanted the lighting to look on the character at all times. So there are 2 different sets of light rigs to do that. Yeah, so you put the 2 together, your environment light, your character light, put them all together, and you get the final shot. The subsurface scattering is really nice. You'll see all throughout this just those little subtleties, the subsurface on the ears, even on the long shots. It's all, again, just using the basic HDRP shader. So with that, we're going to dive into the editor. I'm going to go back to PowerPoint a couple more times just to show you what we're working on, but here we are. So we're in Unity, obviously. I'm just going to hit play here in Timeline, and you can see that this thing will run right here inside the editor. One of the things that I find amazing about the demo team is that they push Unity to the limits. That's what their job is to do, is to really, sometimes we say eat your own dog food, which is kind of the weirdest thing to say, but basically we want to make sure that, we're not developing video games, but we're going to develop these mini productions to really test Unity and make sure that it's doing what it's supposed to do. So they took Timeline and just absolutely killed it. So all this stuff, look at all these different tracks. You're like, well, that's a lot of tracks. Well, there's a lot of tracks inside of these tracks. I can go into like the Alembic track and double click on this guy, and we'll now see inside the Alembic track. And so there's a whole bunch of stuff in there. If you don't know what Alembic is, by the way, a lot of the animation that we see, or I shouldn't say a lot of it, some of the things that we see in here, like the jacket, that's an Alembic cache. The strap that's on the briefcase, that's also an Alembic cache. That's something that you would do in something like Maya, maybe Houdini, whatever these 3D animation programs are. It's a file format that allows you to stream that data in real time. When you think of FBX, you bring it in, you modify it in Unity, do what you want to do with it. Alembic is more of you stream that in, it's already complete. And so those are things, again, some of the things like the strap, as I was mentioning. So let's go back here to our top-level timeline. And, of course, I can scrub through all this. Again, there's that strap I was talking about. Isn't that cool the way it kind of sucks itself up and whoop, makes itself nice and tight? Notice all the particles in the scene. Towards the end of this, I'm going to talk about how the particles were made. But you're going to see as I scrub around the timeline, as I go to different shots, the particles are always being pushed away from both Gawain and the hero character. And they're also landing on the surfaces of the terrain, of the environment, which is all pretty cool. It's always evaluating. It's always running. Even though I'm not even in play mode, we'll still see the particles move. So again, all this moves nicely like so. Let's go dive down just a little bit. And if we zoom in here a little bit, there's this shot where his eyebrow raises like that. So that's where they use the snappers rig. That's where they, and that's just a blend shape rig. If you're familiar with Maya, you have blend shapes. So this is just a little bit of animation on top of that. So I could right click on here, mute that track, and you'll see that his face now gets nice and stiff because that's coming from the performance capture. And then again, if we unmute that, we get the snappers rig on top of it for that extra animation. So combining those 2 rigs together is something you can easily do, and it gives you basically the ultimate control. So you get the best from the photogrammetry and then the best from the control rig. So from here, let's talk a little bit about, again, I was mentioning the challenges of doing a realistic human. So got to go full screen here a bit. There's a little flashing light back there. That's kind of by design, so don't worry about that. But I wanted to show you quickly up close some of the neat things we have here. So subsurface scattering. Check out that ear. The light is coming from that side, so you get the nice, bright subsurface scattering. Subsurface scattering, if you don't know, it's when you take a flashlight, shine it on your hand lights up, ear lights up. It's the blood inside a thin piece of skin. We're not getting it on there because we have that fill light on there, which is just the way this should work. One of the neat things about HDRP is it's physically accurate. So you don't have to worry about measurements. You don't have to worry about, it just works the way the real world works. You're using real world lighting now. When I get into the light rigs, you're going to see things like color, temperature, different types of lighting systems that we can use. And it's all based on the physical world. If we zoom in a bit, let's just talk a little about subsurface while I was mentioning it. If I select his head here, and we take a look at the shader. So here it is. It's the lit shader. And we can see that we've got a bunch of different texture maps on here. I can double-click on, say, the face. I always love the peel-back face. Here's the normal map. If we want, we can get really, kind of crazy with the normals. Zoom out a little bit and just completely make them look old or young. Look at that. It's just a normal map, right? It controls your age. That back the way it is. I obviously have a withered normal map. Ambient occlusion, we've got the subsurface map down here and also the thickness. So if we go back to the ear and I start to move this slide around a little bit, we can see we can control precisely the level of subsurface scattering on there. Oh, let me grab that little guy like so. There we go. And get it back like that. So a lot of control here. Again, we're just using the straight up shader with a little bit of extension to it. Some of the other cool things on here, let me actually get into this mode and make it so we're stop seeing that crazy box around them. Just look at like the pores. Can you see that up there? Look at those pores. Just really, really beautiful. Micro pores, whatever you want to call those. They're really just perfect, combining with the normal map to get that absolutely beautiful look. If we zoom in on the eye, look how wet that looks. Just looks like a real human eye should look. The way the light bounces around on it, you get the fluid underneath there. And I can show you that shader as well. So if we select the eye here, let's take a look. And this one is one that they extended as well. So if we select our eye, where's our little panel for the eye? There we go. So you got these extra controls here. And if we zoom in, we can do some pretty cool stuff with the eye. Things I like about the demo team is they don't mess around, man. You want an eye, you're not going to just get a texture map. You're going to get a whole bunch of crazy controls for it. So we could take like the pupil diameter and do something crazy like that. We can change even just some little tiny bits, like the way the subsurface works on the eye. It's just so subtle. Like you really want that really kind of focused retina and everything. You can pan that over. But again, they give you the ultimate control. The team is here. I'm pretty sure they're going to release these assets really soon, I hope. So hopefully you all get to play with these tools yourself. I had a blast just kind of going through here and having a fun time picking things apart. So a lot of good stuff there. While we're looking at the eyebrow, let's talk about that for a second. So if I go into here, let's take a look at the way the hair was created for the eyebrow. So we're using the hair master nodes. We have the shader graph and the VFX graph. This is the VFX graph, and this is creating the hair. Now, again, we don't see a whole lot of hair. He's got a shaved head. But check this out. If I go and let's grab his hair. What am I looking for? Eyebrow here. And where's that slider? What's on the shader? So here's a shader for the eye. Again, it's using the subsurface using the shader graph here. And if I slide this slider, you can see that I'm able to actually grow the hair. Now, this hair is true 3D hair. So if you see right there, can you see that? Yeah, there you go. You can see that hair is true 3D hair. So we're just kind of magically growing that on the fly. There's also a couple other controls here. So if I get rid of that, we can actually add some hair shadowing. Oops, wrong slider, that one here. So check that out. We get, obviously that looks like a bad Hollywood botch job, but you could just have just a little bit of subtle shadow on there, and look, actually get some shadow down here from when I grow back the real hair, like that. Cool. So using the shader or the VFX graph, we have this thing down here which allows you to basically expose different parameters. I'm not going to dive into this graph here. There's a couple other talks here at the show specifically on the Heretic and also on this graph all by itself, so check those out if you want. But essentially what you can do is when you string these nodes all together, you can expose various parameters. And the reason you do that is if you're more of an artist like me and not the programmer, I don't want to get into all this, well, I could, but I don't, maybe not me, but someone else may not want to get into this kind of a crazy mess, right? They just want a simple control. They just want a couple little sliders here. So these three sliders basically come from the parameters, the same parameter. These right here. This, if you'll notice the same word, alpha clip threshold, alpha clip threshold. So by clicking the exposed icon or checkbox, it exposes these parameters in the inspector. So you could have a technical director, you could have someone more, on the programming side, create these effects, give it to the artist, only giving them a few parameters that they can play with. So if you're doing a larger production, you're not, screaming at people for changing work that they shouldn't change. Just kind of expose what they want to. So again, that's how that was made. Pretty cool stuff there. Some other neat things, even things like the jacket. If I zoom out a little bit, they're using the same hair node, the same hair shader for the jacket. So if we expand this guy and take a look, I have the same sliders, and I can use this to basically tweak the hair, the fur on the jacket. No fur, lots of fur. Interesting, clever uses of that tech. So cool. What else I want to talk about that? Oh, let's do this. Let's do one more thing. If we go into timeline, and let's just take a look at the way the skin stretches. And again, I'm in scene view, so when I'm in scene view, of course, most of you know, none of my post-processing is working. So if you go into game view, it, of course, looks a lot better. We've got all the lighting tricks and everything turned on, all of our post-processing. But then I have a little bit less control over the camera, so I want to get really close in there. So just pop over into game view. But just look at the way that skin stretches. They really spent a lot of time just figuring out the proper way to do that. So you get just, it just looks right. The pores stretch correctly. There's actually a little bit of procedural work going on there to get the pores to stretch a little bit better than they would if you just stretch the polygons apart, which would make them a little more oval. This actually makes it look more like a real face would react. So that's a little bit on how they created Gawain. You could spend all day talking about that, but don't have all day. So let's talk a little bit about lighting. Lighting is such a huge thing for this project. It really just enhances the look of it. It gives you that dark feeling. There's these really just wonderful lens flares going on. These are all custom lens flares that they created, but a lot of them are just using things like a cookie. What is a cookie? Let me show you what a cookie is. If I grab this light here and I move this around, check that out. I've been doing this a long, long time. To have this real-time level quality of lights is just sick. The banding on here, right, the way it looks like a real flashlight would or a real spotlight, that's coming from a cookie. So what is a cookie? If I double-click on this guy, a cookie is just a texture map. Oh, I wasn't expecting Photoshop to launch. Oops. Well, that's going to take 20 minutes, isn't it? Oh, no. Okay, good, because I have a valid subscription. So you're not going to open it? Is that my punishment? Oh, there it is. Okay. Wow, you saw. Curse you. Unbelievable. I thought it was going to open in that little viewer. All right, whatever. It's just a little texture map that gives us those rings, and it gives us that really nice, cool look on there. I did this last night in my hotel, and it worked just fine. I woke up this morning, got here, plugged in, opened my laptop, and it said, your hard drive's whacked. We're going to rebuild your whole laptop. And so as you were walking in, that's what was happening. So I don't know what just happened there. Anyway, that's my excuse. I'll stick to it. Some of the neat things with HDRP, check out some of these lighting things. Things like color temperature. I'm not dealing with colors anymore. I'm dealing with a color temperature. I was really impressed to see a comment last night on the live stream. Someone's like, did I see a color temperature slider? Yes, you did. And there it is. We can also work with things like lumens, candela, lux, things that more real-world lighters are used to working. So kind of getting out of the game space, getting into more what visual effects artists are used to working with, which is one of the neat things HDRP is going to give us, is going to continue to give us going forward. Of course, we can change things, the range of the light. What do I want to do? All right, this is what I was looking for. Change the different types of lights, so a pyramid, a cone, a box. Just look at how the particles light up as I move that around. And I like if I go back to cone, and let's just get this just along the wall. If we start to change things, the shadow map, I would render this stuff take days to render. Now I just move a little slider, can't lie to my boss anymore and say why the computer's thinking because it's just in real time now. Again, lighting is so important. If we grab this around a little bit, let me grab that light again. If you're wondering what this little tool is here on the right, this is something my buddy Mike made, and this is a wonderful little demo tool. It gets you to the right frame, lets you grab exactly the object you want, and just makes doing some of these fast demos a little bit quicker. So if we spin over, look, you can see there's some spider webs that get lit up. Again, all the particles. Volumetric effects are really important in here. So if we go to the corridor volume, and I just turn that off, you can see how much the volumetric effect works. One of the neat things about these volumes is you can have a volume inside of basically like a mesh collider or just a box, or you can have it work on your entire environment. So if you set up a hallway, you can just put a bunch of different boxes and copy these parameters. So as you go through an environment, your effects are always going to remain the same, which is a nice, neat new little feature. If we continue down the shot, I'm going to play this one back. Where are we at here? Let's just go and scrub a little bit. Okay, so if I play this here, I'm just going to go to game view, and let's just play this. Check out this shot. Notice the lens flares. We got a beautiful lens flare there. Another one here, really kind of long. He comes out of that shadow and comes out of that volumetric effect. Gawain comes here and just starts destroying everything. If we go ahead and pause that, and we back up again to here. Watch what happens if I turn off the volumetrics and play this back. It's like lost all of its feeling, all of its mood, right? It's amazing what just something simple as volumetric effects can do. totally different feel. Turn that back on, and the shot just kind of comes to life. Again, these are just simple effects that you just turn on with HDRP. They're pretty much all automatic, and you just get to play with some sliders to make them work. So really cool stuff there. Let's go ahead and stop this. Olympic, I told you a little bit about what Olympic does. We're just streaming in some art assets, so I'm not going to go too much into that. The VFX graph, this is cool. So dust, you see all this dust. Everywhere in this scene there's dust. If I click on some of these different shots, look at the way the dust is always moving away from the hero character. Doesn't matter where it's at, what it's doing, the dust is moving around. Here's just sort of slowly swirling, but if I left this sit for a while, it'll slowly push away. Now right now we are looking at, actually let me open up the dust. We are looking at about 150,000 particles. And this is using, again, the VFX graph. So let this pop up here. There we go. This one's a little bit more complicated. I'll walk you through what some of these nodes are doing. But first, let me just go and bump this up to like whatever I just did there. I didn't mean to do that. Oh, dear. What did I do? Ah! I don't know what I just did. I went in play mode. Uh-oh. I think I did. I started the recorder with a hotkey. And, oh, no. What have I done? Uh-oh. I don't even know what I hit. Back. Oh, geez, sorry, guys. Waiting for play mode to start. Oh, come on back. I went to a car race. I took a photo of a car. There we go. Please don't do this to me. There we go. Okay. Phew. Hello. Just ignore that. All right, so let's go back to, what are you doing? You know, I entered the recorder, right? So the recorder starts to record all these frames. I think we're back. Okay, good. Phew. All right. Remind me not to do that again. All I wanted to do was bump up the count to 300,000, not 30. And, oh, man. Where's my resimulate? Back. Oh, geez. Come on. No pressure. It's only Unite. All right, well, usually there's a little thing that tells me I can resimulate my particles, but it doesn't seem to want to do that. Come on. All right, well, you know what? I'm just going to walk you through what's going on in the shader graph, and hopefully it all comes back. Let's go back to here. There they are. All right, good. And weird. Oh, I know why. Sorry, I got a little flustered with my whole little issue there, and I was in game view. Scene view is where you see this control. Okay, so what I was going to do is increase the particle count to 300,000, and then I did something goofy. If I hit reset, now we're going to see a lot more particles, okay? So it's 300,000 particles, all simulating right now, and they're all slightly moving away from our hero character. Notice some of these particles, they look like little dust. They're moving around. They're tumbling. They're all created here with the VFX graph. Now, if I zoom in, you're going to see, well, let's zoom out first. You'll see there's a lot of nodes going on, right? A lot of stuff. It's really not that complicated. If you've ever used a node-based system like this, I worked at Softimage for a long time. We had Softimage Ice, which was a node-based particle system, which was wonderful. Houdini is very similar. You're basically just controlling individual particles with nodes, but you're controlling all of them kind of with a little bit of variance. So what we're going to do for this particular thing is we're going to calculate a few things. So if I go back here, and I just change one little parameter. So I'm going to go back to game view, go back to scene view here, and I'm going to resimulate these. You'll see they're all moving. If I change, say, Gwen's radius, the radius of our hero character, change that to 5, look how fast those particles are now moving away from him. So I didn't change his physical size. I just changed basically the math that calculates how big he is. If we change that back to 1, you see they kind of move much more slower, okay? So as he moves through the environment, those particles are always going to push away from him. You're never going to see one of those particles penetrate him. And the way that is working is with this graph here. So again, if I zoom out, it looks pretty crazy. But if we just kind of talk about what's going on here, it's not really that bad. So what we're doing is we're using some of these nodes to calculate and store some variables. So we're going to get the distance that each particle is away from Boston. Boston is, again, the bird. We're going to get the direction from Boston. Which way is it going? We're also going to get Boston's radius. And I changed Gwain's radius a minute ago. And that's some of the math that calculates that. That is all getting put into this guy right there, which is the, I don't know what. Oh, I know what's going on. I'm hitting my mouse. It's hitting the HDMI cable and pushing my mouse button. I believe that's what's going on here. All right, cool. So figuring stuff out. So here is we basically did a cut and paste. So we figured out where the particles are, how far they are from Gwain, from Boston, what the radius is. And then we also have the distance of our hero character. So these are just duplicate nodes. All of this here is the same as this here, except one is for the bird and one is for Boston. Once we get those values, we pipe that into these nodes here. And this is just vector math for the particles, which direction and the velocity of the particles are going. Those all get stored, and that all gets piped into here, into our update loop. Here what we do is add a little bit of noise so that they move around somewhat randomly. And then finally they get piped into this guy right here. And this is our final output shader, or our final output control. And again, what we can do is basically expose variables, just like we had earlier. Let me expand this out. And that doesn't want to expand, of course. Whatever. So we have some of those parameters some of those parameters exposed, which is what we see right here. I didn't explain that very well, I know, apologies, but that's basically what's going on. So we calculate where the particles are, we calculate where the character are, and we push those particles. And again, that's always evaluating. Doesn't matter where I go in the scene, we're always seeing those particles move away from our character. Neato. All right, post-processing. Now that I butchered that, come visit me at the booth, and I'll show you a good in-depth view of how that actually is supposed to work. So post-processing. For this, I'm going to make one little change. Let me select my main camera, and I'm going to turn off my main camera and turn on my demo camera. The only reason for that is a lot of this stuff is keyframed, except for on the camera. So if I start messing with my camera here, we're going to see, we're going to ruin my shot. So the new HDRP camera system has a lot of really cool new controls, a lot of real-world things. If we go up a little bit to some of our camera settings, check this out. We can now actually control the sensor type that our camera has, what the ISO is, what the aperture is, the blade count is even in here. So you can get totally real-world camera settings just like you would, in some of the normal more ray tracing programs. And if we go down here, we have things like ambient occlusion, the exposure setting, bloom. If I turn bloom on or off, you can see we have a nice bloom effect there. I can start to crank this out. And this is a much more improved bloom than what we had in some of the other post-processing tools that we created. This is post-processing 3.0, I guess you could say. You can see it really does a great job. Now, we see some of the particles blooming, but we also have, and I'm going to hope Photoshop isn't going to launch. Yay. This is what is actually giving us some of those bloom spots that we see here. So we do have particles that are blooming, but we also have this texture map that's giving us a little bit more enhanced version of that. We can just sort of dial that out or in with the intensity slider here. Same with the scatter slider will give us a little bit more control. But a much better bloom. It doesn't just blow out like that highlight area, high lit area right there. It's actually quite a bit more intelligent, I guess you could say. Motion blur, vignetting. You always got to have a little bit of vignetting because, it's film, right? So you want that nice vignetting. The cool thing that Sylvia was talking about last night is this is film ready. Like, render this at 4K, just get a 4K monitor, capture those frames, and these are now film ready frames. So even though we're not running at 120 frames per second, we're not aiming to do that. This is for a film, so we're going to capture these and then put them in, in Nuke or something like that to then, do our final off with that. Depth of field, of course, I can control the depth of field if we shut that off completely. And I didn't have any on, so we can crank that out, get some good depth of field. We could use the camera settings. Right now I'm in physical camera. I could also go into manual mode, and then I have even different, quite other controls for that. There is the panini projection. This is always hilarious. I don't know if you guys have paninis here, but in the States, a panini is a sandwich. And a panini, you can see it just gives that little bit of lens warp to the center. So it's the sandwich effect slider, like that. much time do I have? Oh, we're getting kind of close on time. Cool. All right, so that's a little bit on post-processing, some of the camera stuff we have going on. I'm going to minimize this for just a second, and we're going to go back to PowerPoint for just a sec, and let's talk a little bit about the bird. So the bird is a completely procedural generated character. When I first saw this, I thought for sure, no doubt, this thing has to be an Alembic cache. This was done in something other than Unity. Nope. This is a compute shader. Why did it say just take, wait. This is a compute shader. This was the concept art for the bird. And as it flies through the scene, not only does it destroy things, it sticks perfectly to the wall, but the artist still has complete control over where it goes, how it goes. Even when it's in this kind of crazy cool flight mode, it's still all being generated procedurally. This effect, this effect. We have splines that we can control. I'm going to show you that in the editor in just a second. We're using what's called a sign distance field to control things like where it is along the wall. So this white texture map right here is actually generated every single frame, and it hugs the wall. So when we're close to the wall, it renders out black, and as it gets a little bit away from the wall, and you can see it happens really quick, it turns to white. So basically, the bird, as it's traveling along the wall, is only allowed to go where this black area is. So this would allow the team to add things like this ductwork, add stuff to the scene, and not have to reprocess this effect every time. They just throw geometry at it. Every frame it's going to evaluate. When I'm running this in real time, it's still doing that evaluation. So I can pull stuff away from the wall, and the bird's going to react over top of it, which is pretty darn cool. And then there's this effect, which is awesome. So we're going to go back into Unity, and let's talk a little bit about the bird. And let's go here to scene view, and I just need to do one more thing, which is go back to my regular camera. So let me turn off my demo camera, turn on my main camera. Good, that's on, perfect. And let's go back to the bird. So check this out. If I just go here, and let's just scrub the timeline a little bit. Where are we at? We're here. If I scrub this a little bit, we can see that the tentacles just move along the wall. So they're being controlled by that sign distance field, which is allowing it to move perfectly along the wall. But check this out. If I grab one of my manipulators, look at that. So this is a compute shader. So the GPU is computing this on the fly. There's a shader that's generating this geometry. It is a real mesh, so you can put all the normal shaders you'd put on it that you'd like. But a very clever programmer created this tool that allows this to move along like so. And if I start to rotate some of these things, if I could grab one of these and rotate it. Come on. There we go. Look, I can twist it around. Oop. Pretty cool. And again, all this is procedural, so no matter what we do to our environment, no matter what we do inside here, the bird will always hug that properly. And I think if we take a look, frame this up, that's the sign distance field for the bird itself. And if we go to the corridor and frame that up, we can see the one that it generates as we move along the terrain. And that usually animates. I think I killed something earlier, but it's all right. Cool. Last thing I want to show you, because we are getting close on time, is the transition. Probably well, I don't know if it's the coolest thing, but it is one of the coolest things in here, is the warp transition. How we go, there's that crazy transition, right? He's inside that kind of a subway or that mechanical tunnel, and then it transitions to a cave. Really clever the way this was done. We have the corridor environment, we have the cave environment. How are we going to transition between these two? In a normal CG environment, normal VFX environment, you would throw this into Nuke, or you throw this into some sort of a compositing tool, give it to the compositor, they do their magic, and boom, it's done. You can't do that in real time. This has to generate inside Unity. We have to see that transition. So they thought, how are we going to do this? Well, how about we think about how wood sliced and do it as a wood slice? So how does that relate to anything, right? Well, think about the spirals inside of wood. And so that's kind of what they thought of with the mesh. So what they do is they take both 3D objects, both the corridor and the terrain. They slice that up into meshes. So they wrote a tool that creates 151 individual slices of both environments. They slice it from the inside, and they slice it from the outside. And if you think of a donut, okay, your donut has a bunch of, well, let's think of a 3D donut. You got a bunch of vertices on the outside, and you got a bunch of vertices on the inside. If you know anything about shape animation, if you have the same number of vertices on two objects, it's very easy to morph between the two. One point goes from here to one point there, pretty straightforward. So what's not straightforward is how they did the slice. So sliced all that up, created the same number of vertices on the inside, on the outside of both the corridor and the terrain, and then morph between them while doing a really cool surface shader on it to give us that kind of cool lighting effect that we saw. And I'll play it back so all this makes a little bit of sense. And then we get this. So these are the individual slices of, in this case, we're looking at the terrain. He's about to walk out into the vista. These shapes slowly morph from one to the other. And I'm using hand stuff to show how morphing works. And then they also get wider. So as they're morphing and changing shape, they're also getting wider. Once the two surfaces touch, they do a geometry replacement, get rid of all those slices, and bring in a new piece of geometry, and that creates the effect. Sounds really easy. It's really kind of crazy cool to watch it happen. It only looks perfect from one angle, right where the camera is. I'll pan out and show you what it looks like in the editor. It just looks like a big, messy, crazy cylinder because we have a lot of UV craziness going on here. But inside the tunnel, inside the corridor, everything looks correct. We'll get back to that. So let's take a look at how that works. And we'll go into our warp transition. Let's take a look from game view. And let's just scrub through a little bit. Where's my time at? There we go. Oh boy, we're getting close on time. So look at that craziness, right? So here he is before the transition. The slicing's happening. Now we got slices, animating thicknesses, and as the slices come together, you can see the thickness change there pretty easily. You see them getting thicker. And then right around there is the geometry swap. Magic, watch this. If you look at this from any other view, it's bonkers. If we zoom out even further, it gets more bonkers. There's all of those slices. Very clever people doing the switch. And there's one, if I get right in, I had found just the perfect angle yesterday that was just blowing my mind. Let's see. Because you can still see him standing there. And there you go. Pretty crazy. And then he moves forward in the new terrain. So just a clever way, obviously a very clever way of doing that. I hope all of this tech comes out. I got some neat videos to show you that they gave me on just how some of that worked. This is using a MIDI controller to control the morphing and some of the rotations and some of the translations on the effect. None of this was actually used, but this is just a cool little example of using some sliders to rig up the transition. See how fast it is, very, very quick. Well, obviously that plays in real time. Show you another cool example here. Oh no, this was something that this was a test that they did. Didn't actually use this one in the shot, but just to kind of make this cool little molten lava looking stuff. And then lastly here, that's the effect as we would see it without the shader on top. So pretty cool. And then the last thing I'll show you is the vista. So we're standing out here, everything's great. This is the setup for the sequel, which was unveiled last night. Hopefully you all enjoyed that. And I'm going to show you one thing that I bet you didn't think. So you're looking at this. I looked at this and went, okay, that's a nice matte painting. No, it's not. I'm telling you, man, the demo team doesn't mess around. Isn't that nuts? Everything is geometry. Everything is geometry. This entire world is in one scene, one Unity project, one seamless project. Pretty darn cool. So anyway, that's a little bit of a look at how this was made. So sorry we had that little technical snafu there in the middle. I do want to mention a couple other things really quick. If you want to know more about some of this stuff that we talked about, we have our Premium Learn is available now. You can learn all about things like the post-processing stack. You can learn about particle systems, what I showed you. You can learn about the shader graph, all that kind of stuff. So lots of good knowledge on there. There's a free code on there that's going to get you some discounts and get the 3-month trial. So thank you all very, very much. I'll let you all get a picture of that. My name's Mark Schoennagel at Unity3D Mark S if you want to send me a tweet. Otherwise, thank you all very much. Thank you for being here, and see you at the next one. Woo-hoo.